Greetings and welcome, friends. I was just talking to my algebra buddies about how they felt when all of a sudden letters started showing up in their math. And today, we're going to replace even the remaining numbers with more letters. And that's going to be crazy. It's going to be crazy. I love it, though. Today's lesson is about solving literal equations. Literal equations. Let's figure out what a literal equation is. An equation that has two or more variables. All right. Previously, we've had, gentlemen, one variable, usually x, but also we've had h or y or z or different things like that. But we've only ever had one variable for one equation. And as a result, we've been able to solve the value of that variable that made that equation true in that moment, right? You tracking with me? I don't know. I think I've only got like 3 people actually listening right now. That's okay. So check this out. When I have more than one variable, so if I have 2 or more variables in an equation, I won't be able to find a number that will make the equation true. But I will be able to rewrite it in terms of one of those variables that I would have a remaining kind of equation that tells me this is true for all of these values of whenever the other variable fits in here. Eventually, later on in chapter 5, we'll actually talk about finding 2 solutions simultaneously, but that would require 2 equations with 2 variables, but it is not this day. All right, so when we solve a literal equation, you solve for one of the variables in terms of the other variables. So notice it's not going to be like x equals 2 or y equals 7. It's going to be like y equals x plus 2. So my solution for y will have an x hidden in it. All right, and so that's going to be a little bit different. So here's example 1. It says solve the literal equation 3y plus 4x equals 9. And they want me to solve it for y. All right, so my target, actually I'll do it in purple, is this. I want to get the y by itself. Question? Gretchen? All right, cool. So when I'm solving for y, I'm going to pretend, using my imagination, that x is just some number. All right, just pretend that x is a number now. Okay? So that's what I'm doodling. So I've got 3y plus some number equals 9. How do I get y by itself? Nope. 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 The guesses, by the way, internet audience, were subtract 3 from both sides and divide by 3. Dividing by 3 is going to create a fraction here that I wouldn't want to deal with. Now, I'm going to move this to the other side. Yeah. I would have to divide both sides by 3 if that was my move in their entirety. Another way you could have written that is, yeah, each term divided by 3. Yeah, and that just, yeah, that's not fun. Now, remember, plus 4x is just some number. Imagine it said plus 42 or something like that. So I want to move this to the other side. So I'm going to subtract 4x from both sides. And now when I do that, I'm going to write this in front of the 9. Okay, because 9 and negative 4x, those aren't like terms. So I can't combine them, right? They're apples and oranges. But I do want to write my variables in front. That's one of the common traits of algebra. So let's see. So I'm going to have 3y. These 4x's canceled out, so equals, and I'm going to write this as negative 4x plus 9. If you wrote 9 minus 4x, that's also true, but like I said, we typically write our variable term first and then our constants. Okay, now how do I get y by itself? Yeah, I'm going to divide by 3 here, and I could do the entire side, but I think it's usually better to divide each individual 10 by 3. So I'm going to have these 3's cancel out. I'll have y equals. Tell you what, I'm going to take this x and move it just kind of out to the side. So I'm going to write this as negative 4/3 x plus, what's 9 divided by 3? 3. And this is actually my solution. I've rewritten this equation in solve for y, but it's in terms of x and some other constants. A little side note real quick. In terms of negative 4/3 or 4x over 3, and I feel like it's skipping some writing. That's the same as negative 4/3 x. It is not the same as negative 4 over 3x. Okay? So this one is a no-go. All right? But I can have either the x in the numerator or kind of on the side. The value of putting it on the side will show up in 2 chapters. There will be a benefit to writing it that way. Okay, so this is my answer. Okay, this is my answer. Now, actually, in terms of this last step, I could have alternated and done it slightly different, because like I said a moment ago, I could have, so this is alternate reality. I could have divided the whole thing by 3, and I would have had an answer that looked like this: y equals negative 4x plus 9 all over 3. These are both equally true. That's fine. That's fine. I tend to like this one better, but I just want to point out those things are both true. There may be multiple ways of writing the same answer. Okay, so just so you are aware. Let's do a couple of these monitoring progress questions 1, 2, and 3. Let's see. So you guys have this in your notes as well. So let's see here. They keep wanting me to solve for y. They may ask us one day to solve for x. All right, just so you're aware, if I'm solving for x, I would get everything away from the x, and my answer would be in terms of y. When I'm solving for y, I get everything away from the y, and my answer is in terms of x. Oh, that's unfortunate. All right, so here I'm targeting the y. I'm going to pretend everything else is just a number. All right, what should I move first? Yeah, I'll add that x number to both sides. Okay? And so I'll have 3y equals, and I'm going to write the x in front of the 9. I'll write that as x plus 9 rather than 9 plus x. And this problem is actually very similar to the last one. That's weird. So y equals, how could I rearrange x over 3? Watch this. I'm going to write that as 1/3 x plus 9/3. Nope, 9/3 is the same as 3. But if you wrote x over 3, then plus 3, that's fine too. That also works. That also works. All right, let's try this question. Here we go. I'm trying to get this y by itself, so I'm going to pretend every other variable is a number. What should I do to both sides? Yeah, so good, so good. Sometimes when people see this minus sign, they're like, oh, I've got to add 2x. But that would not be true. This minus sign belongs to 2y. The 2x here is already positive, okay? So I've got to subtract 2x from both sides. That's a legal move. So I'm going to have negative 2e is equal to negative 2x plus 5, or 5 minus 2x, but or one better, what else could I do? Divide by negative 2, yeah. And every term gets divided by negative 2. So I'm going to get y equals negative, ooh, look at this, negative divided by negative is positive. 2 divided by 2 is 1, so that's just plain old x. You could throw a 1 there, but really, it's implied. And 5 divided by negative 2, instead of writing plus 5 over negative 2, I'm just going to write that as minus 5 halves. I mean, if you're like a mixed fraction or a decimal person, you could, but for the majority of the time, we'll leave them as improper fractions that are fully reduced. Yeah, yeah. Let's have you guys try question 3. I'll leave these up on the screen. Yeah. Internet friends, you can try this at home. I'll be back in a moment. My front, yeah. No question. The answer is when the filter. All right, mis compadres. Let's see. So I'm pretending the x is a number. To move this is a positive 8x, so I'm going to subtract 8x from both sides. You with me, friends? Amigos, compadres, estudiantes? Gracias. So I've got negative 8x plus 20, right? That's a positive 20, equals 4y. Oh, yeah, some of the equal signs were looking like minus signs for some folk. Might have been it. Yeah, it doesn't print the best all the time. Now, how do I get y by itself? Divide everybody by 4. Yeah. So I'm going to have negative 2x, yep, plus 5. And better yet, let's rearrange this. Yeah, no es más mal. Es el más bien del mundo. Let's see. Oh, yeah, I skip example 2. I don't like it. Oh, man, crazy sauce. Mm-hmm. All right. We also, so those were just x's and y's, but maybe you're familiar with some different formulas for area or volume or things like that. It's also possible to rearrange things with formulas. Yeah, I think I'm going to skip example 3. You're welcome. But let's take a look at example 4 first. And then we'll do a couple monitoring progress ones as well. Let's see if I can screenshot this little picture here. All right. Yeah, the frontage. So a lot is a lot of property. And frontage is the edge, the linear distance that your property touches a road. And some cities actually have limitations on frontage as far as how many ways you could subdivide that property. Is like each time you would break it up and try to sell it as 2 properties, each property needs to have a certain amount of frontage for the road. Question? Mm-hmm. Wow, so you've got like maximum frontage for your house if it's got 3 sides, 3 roads. All right, so here it says, find the frontage of your lot. Let's see. Okay, let's first verify some of these things. Your own rectangular lot is 500 feet deep. Bam, 500 feet. It has an area of 100,000 square feet. Okay, 100,000 square feet. To pay for a new water system, you are assessed $5.50 per foot of frontage, of lot frontage. Okay, let's first figure out what's the frontage of our lot. Now, question, oh, wait a minute. If this is W and this is a rectangle, then the width is the same here, is here, is here, is here. So yeah, I think my frontage is W. Hold up, hold up, hold up. Do you guys agree that this is the width as well? You guys see how I translated that, Jacob? To the other side of the rectangle, W is W no matter where W is. All right, and also this is a rectangle, and I saw the word area. Does someone know a formula for the area of a rectangle? Yeah. A is equal to length times width. And in this case, the length is the 500, and the width is my yet to be determined value. Question. Let's find out. Let's find out. So, let's do this first. Let's find a formula for the frontage of my lot. Okay, so for part A, let's write down this formula. A is equal to L times W. How could I solve this for W? Question, comment. Oh, we'll get there. We'll get there. You're already solving the real problem. I'm solving the formula first. How could I rearrange this formula so it's no longer a formula for area, but it's a formula for the frontage of the lot? Right, Jacob, you with us? Yeah. No. No. How could I rearrange this formula so it's solved for W? Now notice there are no numbers in this formula. All right, guys, quiet. Listen to me. There are no numbers in this formula. Any variable besides W, I'm going to pretend is a number. How would I get W by itself? No, you're still talking numbers. So I'm going to divide both sides by L. So notice I would get A over L is equal to W, or I could rearrange that as W equals the area divided by the length. So this is a formula for the frontage of the lot. It's no longer solved for area, it's now solved for W. Okay? So now, right, I could do this two ways. I could plug in what I know and solve for what I don't. Right? So if I was using this, I could say find the frontage by doing W equals the area is 100,000 divided by the length, which is 500. And that's what you were telling us the whole time, right? I just need to divide those two things. And I'm going to reach for my calculadora. Actually, watch this. Pro tip. I think I could cross off some zeros here. Whoop, 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 whoop. Right? 1,000 divided by 5. Do you guys know what that is? I think that's 200. What unit is that measured in? It's actually just plain old feet. This is a linear dimension, so it's just feet. This is a linear dimension, that's just feet. But when I multiply feet by feet, I get feet squared. And that's where area comes from. So this is one way you could have done it. Another way, I could have actually plugged in the original formula. I could have had 100,000 is equal to 500 times W. And if I'd solved this equation, I would have done exactly the same work I did here. Divide both sides by 500. And you would have gotten the same answer. Okay? So I just want to point that out, that it would have worked out the same way. How about part B? It says, how much are you assessed for the new water system? Thoughts? Yeah. All right, yeah, I'm going to take the frontage, which is W, and multiply by 550. So I'm going to take 5.5 multiplied by 200. And I get $1,100. I'll just, okay. So there's the cost. There's the cost. All right, guys, let's take a look at let's look at these questions 7 and 8. You have a question? All right, I don't think any of these questions are related to the algebra, so we'll move on. Let's take a look at these two problems. I'm going to have to shrink this one down. There we go. Question 7. You guys recognize this formula? The area of a triangle formula. All right? Half the base height, right? There we go. They said solve this formula for h. So instead of an area of a triangle formula, they want a height of a triangle formula. How could I get h by itself? All right, okay. Don't write this down yet, but someone did say divide by 1/2 b. Nope, I wrote h. I just wasn't done writing it. There we go. Do you guys know how to divide a fraction? by a fraction? That's actually tricky. How do I do it? No, you're thinking adding fraction. Now, another way, Trinley, to deal with getting rid of multiplying by a fraction, I can actually multiply both sides by its reciprocal. You guys know that trick? So not opposite would be a positive and a negative. Reciprocal is the flipped. Yeah, you got it. You got it. You're tracking with me. So notice these 2's would cancel out. The 1's, well, whatever. I would get the following. I would have 2a is equal to bh. I multiply both sides by 2. Yeah, I wrote that a little tiny. How do I solve for h now? Divide both sides by b. I'm just pretending that b is a number, right? That's a 2. Actually, good question. My 2's sometimes look like this, sometimes loop-de-2's, but my z's, I'll always put a little line through it, so that way you can tell. But yeah, I agree. That done looks like a z. So I'm going to have 2 capital A over little b is equal to h, or better yet, h is equal to 2a over b. And so now here is a formula for the height of a triangle when you know its area and its base. Yeah? All right, look at this one. This one's getting even crazier. So this is a surface area of a cone. Yeah, you've got like the radius here, and this is L is the slant height. Did you guys know that? Yeah, there you go. And yeah, so there's the radius. But either way, they gave us a formula. I'll write it larger. S is equal to pi r squared plus pi r L. Oh, wait. What variable is this? Yeah, you do. Is that a variable? No. Pi is not a variable. It's a constant, Ben. And it's a constant that is innate within our universe. It's a number 3.14159, infinitely long, non-repeating, right? And it's the ratio of circumference and diameter for any circle, okay? So those represent numbers. Now, they asked us to solve for L. So I want to pretend that pi is a number, which it is. I want to pretend r is a number, and I want to get everything away from the L. Yeah, it does look like a cool fish. So what do I do to both sides to get L by itself? You could, and actually in this case, it's not a bad move because fortunately here, this also has a pi and an r in it, but I'm actually going to wait to do that. Now this whole thing is a number that's being added to, right? So I'm going to just subtract pi r squared from both sides. No, I got pi r squared here. Both sides of the equal sign, right? I'm not subtracting it from here. So notice I'm going to write this side as s minus pi r squared equals, these canceled out, pi r L. And you weren't wrong when you suggested divide earlier. I just prefer to move this one first because more frequently we'll adding or subtracting, right, we sad map because it'll avoid fractions more frequently, at least until the very end. So let's see, pi and r are being multiplied by L, so to get rid of them, I would divide both sides by pi r. And so I'll have s minus pi r squared over pi r is equal to L. And then you could obviously flip that around if you want. Now this isn't the only way to write this formula. So this is the slant height of a circular cone formula when you know the surface area and the radius. Okay? Also, yeah, just so you're aware, I also could have written it this way. S over pi r minus pi r squared over pi r. That I could have divided each part over here by pi r. Does anyone know how to simplify this? What cancels out here? The pi's cancel out. And this r cancels out with just one of those r's. Wow, good move. Yeah. Yeah, so it also could have been written as slant height is equal to S divided by pi r minus r. Yeah, a little bit. All right, let's get one last example in here. It does look like a square root. I agree. So yeah, there's two different ways of representing that. So guys, notice the only number in here that looked like a number was the number 2. And everything else was like letters or even a Greek letter. That's craziness, huh? I'm telling you, I've been training you for this boss fight here. Here's a couple examples of some other formulas that you might see within this chapter. This is how to convert temperature from Fahrenheit to Celsius. Here's a simple interest formula. And here's, we saw that one before. Distance equals rate times time, guys. Let's do example 5, though. Last example, and then we'll do some Desmos. All right, this is the trickiest problem of the day. Here we go. What if I wanted to solve this formula for F? Well, you can write it down. You've got it up above it. All right, are you still texting? All right, just kind of, yeah. So Ben, man, this problem's crazy. What do you guys think I should do? If I want to solve for F, yeah, you got to write it down. You guys didn't have it already. You might say, hey, Mr. Waddy, we could distribute. You could. I'm not gonna, though, because I don't feel like it. What was the way I told you we could get rid of multiplying by a fraction? And dividing by a fraction is the same as multiplying by its reciprocal. So what's the reciprocal of 5/9? 9/5. 9/5, yes. All right, so notice how cool this is. The 9s will cancel, the 5ths will cancel, although that made it look like an 8. So 9/5 times Celsius is equal to, hey, notice I've just got F minus 32 now. Now what do I do? How do I get the F by itself? Add 32 to both sides. And so I'd have 9/5 C plus 32 equals F. Or you could flip it around. F is equal to 9/5 C plus 32. And so notice the benefit of this compared to the original one. This one works when I know F. This one works when I know C. Right? So if I know C, I would just plug C in and I'd be able to convert Celsius to Fahrenheit. So being able to rearrange formulas like this is a helpful skill now made available to you by the algebra. All right, thanks for watching, internet friends.